All right, hello, welcome everybody. Hope you all had a great weekend. Well, I'm sure you're already aware, but the first homework assignment is due today. I think I already mentioned last time that I'm not gonna be like super strict on deadlines. I don't even remember what time I said, but get it in for me. Get it in today. Probably not even gonna look at it until tomorrow because I'm in class all day today. But I will probably start looking at them tomorrow. So I checked before class. It looked like a good number of people got the server stuff done and the little written part of it as well. So I haven't heard of any huge problems, although I did chat with some people over the weekend about some small problems on the assignment. So that was good to do. Just want to make sure you all know that I am aware of the fact that I'm the only human resource for this class, and so I do try to respond to questions for this class pretty quickly. So if you say CSE237 in your email, chances are I'm going to see that and try and get back to you, just because I know that I am the only person who can help you out with that. So don't want you to feel like you're going to be left hanging if you are still working on this homework assignment. I do, sleep and other stuff like humans do, but I will try to get back to you as soon as I can. And the next homework assignment's going out today. I'm going to talk about that a little bit more towards the end of class today. But just one more time, so that everybody can hear this in case they need to hear it. If you're struggling with due dates, let me know. I definitely would prefer to know prior to rather than after the fact, but at least give me some kind of a heads up. We can talk about it. I will accept late assignments. I won't accept super late assignments. I would prefer not to do that, but I will accept late assignments, especially if you give me a heads up. Preferably ahead of time. I like to think that I'm pretty reasonable, so just let me know what's going on. If you need help, if you need a couple extra days, it's probably not going to be a problem. Just need to know about it. Any questions about homework assignments right now, or schedule, or anything before we hop into scripting, which is our topic of the day today? Cool. We'll chat about homework assignment 2 towards the end of class. I want to talk to you about some scripting stuff first, because actually everything that I'm going to be showing you today is going to be very relevant to the next homework assignment. I'm going to be using Vim a lot today to write all of these scripts. To be fair, you don't strictly have to do that. If you would rather open up Visual Studio Code or something else to write these scripts in, I'm not going to give you too much trouble over that, although I do think it's a good chance to practice Vim, which is something that I do think is a valuable skill. That's why I spent a whole class talking about it. So, I would encourage you to at least give it a try. Follow along with me today as I write some simple scripts. And if you absolutely really hate it and you want to use VS Code for the homework assignment, okay, cool, that's fine. Not gonna worry about it too much. I really hope you at least give it a try, though. We're gonna do scripts today. So we're going to start from the very basics. Start with the very basic hello world script. I've got my command line open. In fact, I'm going to make a new folder just to play around in today, just to keep all this stuff separate from my other work stuff so that I don't mingle it all together. You don't have to do this if you don't want to, but I'm going to. I'm going to call it scripting 24. And then I'm going to cd into this brand new folder. And I can run ls real quick, show that it's empty, right? Just made it a second ago. There's nothing in it. And so what I want to do is just make a bunch of scripts today, show you what we can do with scripts and why they're so useful. Basically, we're automating tasks, automating commands on our computer. So all of the commands that I've taught you about, plus all of the commands that I haven't taught you about, because there's so many of them, right? All of them can be used within a script. So cd, the command that most people learn, is one of the first ones. That can be used in your script. ls can be used in your script. Echo, which is our print statements, right? We're going to be using those a lot in our scripts to help us understand what's going on today. And then I think once you sort of get the idea of what can be used in scripts, you can start to see that they're very, very, very powerful tools that allow us to process lots of files, lots of commands very, very quickly. But we're going to start simple. Let's start with a simple hello world script, and pay attention to how I'm doing this. I'm using Vim, so I'm going to use Vim today. And the name of the file I'm calling hello.sh, where the .sh is, I don't know if I would call it strictly required, but it's definitely strongly suggested. It stands for shell script. .sh. If you see that on the end of a file, you're probably looking at a shell script. That's what that file extension represents. So all of the files that I make today are going to be shell scripts. That's what we're going to be using. This will dump us into a very blank, very empty Vim file. It even tells me down at the bottom it's a new file, right? It didn't exist before. It does now. And so I want to start typing. There's nothing really for me to edit, so we're going to not worry about all those fancy commands and modifiers and all that stuff. I'm going to go ahead and hit I, which dumps me into insert mode. And the first thing that I'm going to put up at the top is called a directive, or you might hear it referred to as a shebang, where the hashtag is the sh and the exclamation point is the bang, shebang. /bin/bash. I know the black on blue is probably a little tough to read. I wonder, oops, that's not what I wanted to do. Pasting some weird article I read on the internet. It's trying to change the color of the tab. So we could, well, that's not going to do it though, is it? No, yeah, that's very useful, thank you. Okay. Well, hopefully you all can see it okay. It says /bin/bash. So I've got the shebang /bin/bash. That is telling us that this is a bash script, as opposed to one of the other types of shell scripts that are available. So I know Z shell is one that's used on Mac OS X. Let me see if I can still figure out a way to change this. Really want to change the right click, ain't it? Okay, whatever. I'm just gonna soldier ahead. The hash by itself can be a comment. So this is just a comment that I'm putting in here, and then the actual command, echo, that's just a print. And since this is our hello world example, it's just going to say exactly that in quotes. I hit return at the end there. It is actually considered somewhat important to make sure you leave a blank line at the bottom. You might see why that is in fact the case if you ever forget to do that, which I might do later on today, to be perfectly honest with you. This is my entire script. So the only two lines that are actually doing anything are the one at the top, the directive, shebang /bin/bash. We're actually saying this is the shell that I want you to use to run the following commands. The bash shell. And then the print statement, which is just going to say hello world, hopefully, if everything goes properly. I need to save this file and get out of Vim. So I hit escape to get out of insert mode. Then :WQ, that's what you see down there at the bottom. About to hit enter. It takes me back to the command line. Here's the color settings. All right. Let me switch it. So that I can hopefully see a little better. I'll restart this real quick. Sorry. Did that even change my colors? Didn't. I am not doing computering well today. I'm sorry about that. It's Monday. It didn't even change my colors. Great. All right. Well, I'm going to stop wasting time on it. I'm sorry that I wasted so much time on that. I'm back to where I was. There's my script file. It has the contents in it that I wrote to Vim. If you want to verify, there's actually a command that we can use to see the contents of a file. Anybody remember? It's the name of a four-legged furry animal. Cat. Cat tells us to just dump the contents of a file. So if you ever want to see the contents of a file real quick on the command line, type cat followed by the name of the file. You can actually see the directive properly now, so that that text was bothering you before. How do we run this thing? If I type hello.sh, it says, I don't know what you're talking about. And this is another very commonly asked, confusing thing for people who are new to the command line. The file is very clearly there. I just made it. I can see it in ls, right? I can see the contents. So I type the name of the file. Shouldn't that make it do stuff? Well, no, it doesn't. We actually have to start with / out in front of the file name. To think about what / means, we've seen .. before, right? What's .. represent? Going up a level in the file tree. So go to the folder that contains this folder. That's what .. means. A single dot just means here, where I am right now. So single dot means look in this folder, find a script called hello.sh and run it. So when we put the / out in front of the name of the script, it actually finds it properly and runs that script. And our script is very simple, just a print message. Nothing too fancy going on here. We're going to change that in a second. Obviously, we want to do more than just printing stuff. If that doesn't work, this is a very common issue. Sometimes it'll say permission denied or something like that. Then we need to check something else. If I type ls-l, I'll see over here, what are these again? These are called some long word with a P. Permissions. These are the file permissions. These are the file permissions. So this would have been the topic, I believe, that was discussed. I don't remember if we did this on the first or second command line day that we had, but they're in groups of 3. So it stands for read, write, execute, read, write, execute, read, write, execute. So basically, this is me, the owner of the file, which is me. You can see right there. What permissions do I have? I can read, I can write, I can execute. This stands for the group. I almost never use these. I almost always ignore them. And then this stands for everybody else who is not me, right? What permissions do they have? Well, they can also read, write, and execute. Maybe that's okay if it's just your computer. You don't expect anybody else to touch it. But if it's on a server or somewhere public, you might want to think about restricting this. For our purposes today, since I'm trying to run this is a script with commands that I am trying to run, it must have this X flag activated. It must be executable. It must be runnable. And if you need to change that, anybody remember the command? To change the permissions? Yeah. chmod is right. Chmod is right. Chmod followed by some numbers. There's 3 numbers, one for each group of 3. So 7 is all of them. 7 means 3 ones, 111, right? It's binary. It's a binary digit. So a common one would be like 755 would say, the 7 is for me. I can do everything, read, write, and execute. The 5 would be just reading and executing, but you can't change anything, right? So that would be a common one. Or 777 is what's listed right now. Everybody can do anything they want. It's just there, open to the world. But in order to be executed, you have to have that last bit set. So if you need to change the permissions on it, you can change it to 755 followed by the name of the file. This won't do anything for me. I already had the permissions I needed, but if you need to change that, that is sometimes a necessary step. All right, let's do some more scripts. Let's do some actual stuff. We'll do some mathy stuff next. Oh, that is a very different topic. All right. Math. Always at the top. I'm going to put my directive, and I actually made a mistake that I make all the time. The exclamation point comes second. So hashtag exclamation point /bin/bash. If I want to add some things and store the results in a variable, I'm using 2 parentheses, not just 1, but 2 parentheses. followed by the name of the variable equals, and then, you know, whatever math you want. This should, if I did it properly, create a variable called sum that stores the result of that arithmetic. And I wish to then, you know, see that displayed on the screen. So I'm going to put an echo statement to try and echo that variable sum back out. Let's give it a try. You might be able to tell by the way that I'm talking that I'm concerned. I know that I've made at least one mistake, intentional mistake. There are other mistakes that I'm concerned about having made as well. But let's see how far we get. Oh, okay. That's the one I knew about. So, almost, but not quite. I just got the word sum. I was hoping to get the contents of the variable there, not the actual word sum, right? I was trying to make a variable called sum and then see the actual contents of the variable. So let's go back into the script and see. It's got to do with this print line. Whenever you're printing variables, you actually have to append a dollar sign out in front. So make sure you stick a dollar sign out in front of your variable, not when you create it. Notice that up here, when I am assigning the variable, it just looks normal, right? No dollar sign. It's only when I'm printing it out. So the dollar sign is an indication to the print statement that I wish to see the contents of this variable called sum. And now, okay, that looks a lot better. Now I see an actual number. The other thing to pay attention to, that trips people up on this stuff is the double parentheses, right? Don't forget those, because if you take them off, you can potentially get some weird effects. Yeah. So you can see that it interpreted things very differently once I took that second set of parentheses off. It's trying to interpret this as a command, and it's not a command. I was trying to use it as a variable. Both of those sets of parentheses are necessary to tell our bash script that we're doing some math here. We're doing some arithmetic. The good news is that I'm usually not using bash to do math. That's not really what it's for. It's used to automate commands. And so that's really what we care about, is running commands within a bash script. So I'm going to make a new script called command.sh. And I always have to put that directive up at the top. So shebang, bin bash. And now I want to call ls. So I can do that. I can call ls. It's totally fine. In fact, if I wanted to, I could just say, we're done, this is the script. It's not a very useful script, it's just going to call ls, right? What if I wanted to capture that within a variable? Well, we can do that. I can put the name of a variable. You may have noticed by now as well that variable names are traditionally all caps. I don't think it enforces that, but it's definitely expected that your variable names will be all caps. Also, too, pay attention to the spacing of your equals sign. I know that sounds ridiculous, what I just said, but it is absolutely 100% true. Notice that if I put a space in between, the color changes, and that actually will derail your script. The equal sign has to be right up next to that variable name, giving it a nice hug, or it's not going to work. And that's going to happen to somebody on the assignment, I guarantee it. Happens every semester. Happens to me. I forget that too. It's kind of annoying, but it is what it is. All right, so instead of just saying what ls is, I'm going to actually capture the output of ls and store it in a variable. That's what I'm doing here, right? I am capturing the output of ls and putting it in a variable called output. So go run the ls command. That usually tells me the names of all the files in a directory, right? The current directory that I'm in. And then put that into a variable called output. And then So if I run this by itself, what's going to happen? Anybody know? Big fat nothing. It captured that output and stored it in a variable, and then I never told it to do anything with that variable afterwards. So if I actually want to see the contents of that variable, we can print it out using echo. In a more realistic scenario, we probably wouldn't just be printing it out. We would be doing some processing on it, right? Look at each file in the output of ls and then do something with that file. That's something that we could potentially do. We don't have all the tools just yet, but we're getting there. Let's try just this simple printout for now. Okay, right? So it's running the ls command, capturing it in a variable, and then displaying that. So it's really no different than, just running ls directly. But I'm trying to show you the building blocks that we can do here. Let me show you something else that's important when it comes to scripts. Now is a good time to talk to you about your working directory. This is actually one of the first things that I talk to you about, but it's going to become very, 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 very important. It was already kind of important on the first homework assignment. It's going to become very important on the second homework assignment. As you are going through these scripts, it is very important to always keep track of where you are. And by that I mean specifically what directory you appear to be in. Because it is very possible to bounce around and change directories, right? I could come here and say cd ... and then, run the ls command again if I wanted to. And think about the effect that would have. This line's kind of redundant, actually. I should have just skipped. There we go. If I put this cd ... now it's going to go up a directory first, capture ls from that directory, and then print that out, right? But up a directory from where? It's tricky. It's a tricky question. Let me show you the answer. Woo, okay. So when I run the script from this directory, I'm looking at the result of ls from one level up, which is my home folder. It's got a bunch of junk in it. It's got way more stuff. But that's the point I'm trying to make, is it's all relative. It went one directory up from where I am and then ran the command. Well, what if I do something a little, I don't know, I could actually run the command from here, right? Go up a directory, type the name of the folder, followed by the name of the script that I wish to run. Okay. Now I ran the exact same script, but I ran it from the directory one up, right? And so what did it do? It still ran cd ... and it went one more level up. So what is it doing? It's relative from where I run the script. It's relative from where I run the script. It's very, very important to always keep that in mind, right? Let me go back into this and show you, right? If I do cd ... here, I now know that all of the commands that run afterwards are going to be taking place not in the folder where I started, but in the folder where I told it to go. Yes?
How come you don't need the dollar sign for the CD? Or why do you need it for the LS instead?
The dollar sign is capturing the output and storing it in a variable. That's its purpose, is to say don't just print it, but actually capture it and stick it in a variable. Whereas this is, I'm just saying do it. Just go there, right? One thing that you might consider doing, or that you actually will be doing on a potential homework assignment coming up, hint, is like, I'm in a directory that has a whole bunch of other directories, and I wish to visit each one of them, right, one at a time, and do something inside of each one of those folders. That's not an unreasonable thing to ask. It's not an unreasonable thing to conceive of needing to happen, right? I've got 10 different folders that have homework assignments in them. I want to write a script that goes in each folder and grades it. okay, so I can CD into homework number 1 and run some commands, right? But then I have to remember to get to homework number 2, I'm going to have to back out of there first and then CD into homework number 2. And I'm going to have to back out of there and CD into homework number 3. You have to keep track of where you are. You have to have a mental picture of what directory you're in to know what commands you're in. Because if I come back here and say CD into scripting 24 again, right? Now the commands are in the original folder where I started. Although, wait a second, does that directory exist? Sometimes yes, but depending on where I run this script, what directory I'm in when I start, maybe that directory doesn't exist in that folder. You have to be careful about that stuff too. All things that you need to keep track of. I'm not saying this to scare you. I'm saying this because this is one of the more complicated pieces of keeping track of our scripts. Yeah. I'm going to show you one more example, and then we're going to do an exercise. Done with this one. Let me save it. Actually, I'm going to take the cd out. Leave it like this. The last one I'm going to do is input. So I'll put my shebang up at the top with /bin/bash. And this is similar to what we teach people, in 131 with the scanner. Do a prompt. The command is read, followed by the name of a variable. So actually, I would prefer to see this probably all capitalized, right? Doesn't have to be, but by tradition. And then if I want to, I can print that variable back out, although we can do some concatenation, right? Take a look at how concatenation works. Those of us used to doing it in Java or other stuff probably wish we saw like a plus sign in here, but we don't have to do that. Putting the $sign out in front of the variable name eliminates that need. It knows this is a variable and we'll just substitute that value directly into quotes. That's handy. That's a useful thing. Okay. So I'm going to run this script now. And it's telling me to enter my name, and so I should be able to type in my name, and it'll say hello back. But that's powerful, right? I now have shown you, yes, it's just a simple little hello reader program, but I'm also showing you this is how you can get your user to type something into the keyboard and capture that into your program. That's a useful thing to be able to do. We're also going to use that read command to read values in from files. Read values in from files, which is actually something that we probably prefer to do more than asking people to type in usually, at least as it relates to your upcoming homework assignment. Yeah. All right, let me pull up some exercises if I can remember where I put them, because that's our next step. 237. Here we go. All right. Here is your first task. It's got 5 steps in it. You can talk to your neighbors. You don't have to do this by yourself. You don't want to, but take a look at these 5 steps here and make a little script. Ask them to type in the name of the directory they want to create. Go into that directory. Print out the path to the directory. Think about what command that was. We've talked about that, but it's been a little while. Then go back to the original and delete the directory. The nice thing about this one is that after the script is over, it'll look like that folder never existed. It only exists for the lifetime of the script. It's kind of interesting. Right? See if you can take a crack at it. We'll go through the solution in about 5. actually. There we go. Okay, I got my solution ready to run it actually. Step 1 was to prompt the user to enter the name of a directory we wish to create, so I'll just call it test or something simple. Should read that in, create the directory, print out the path to the directory that was created. So here it is, the full absolute path starting from the root over here on the left. There's the name of the folder that I told it to create, right? There it is, right there. This is our proof that the folder was actually, the directory was actually created. It actually exists at this moment in time. It should then return to the original directory and delete the directory that was created. So if I do ls right now, I should see that, oops, it did not get deleted. So I skipped a step. That's okay. I think I did all but that last step, actually. I can rm-rf would do it, or I think since it's empty, you could use rm directory. Let me show you the script and add that last piece in that I forgot to do. There we go. So the first task was to do the prompt and then use the read command. Whenever you create the variable, you do not need the $sign. I actually made that mistake when I was coding the script up. I put the $sign on the line that had read on it. You do not need the $sign when you first create the variable, only when you are referencing using that variable later on in the script. So you can see that all of the other commands in which I need that value, I do have the $sign. So it says to make the directory, and then it feeds the variable name in. I'm now making a directory based on whatever the user type is. And now it's CDing into that same directory, just accessing the variable to use CD into that directory. PWD, that's one of the very first commands that I showed you in this class. That stands for print working directory. That's what takes care of printing out the full absolute path, starting from the root, drilling all the way down into the file system until it gets to the directory that was created. CD ... just takes me backwards, and then removing the directory was that last step that I forgot, but now that I put that in there, it should take care of that little omission. One final thing, I guess, that I want to bring your attention to, sort of along the lines of the idea that I showed you before. Notice that if I take out the last couple lines of this, right, script, let's just say I don't want to do the last step or two, and then I run it, I'm starting in the scripting directory, but look at where I end up. Well, I stay in the scripting directory here, but within the, I guess I didn't really do a good job of making my point, did I? Oops. Gosh, I cannot type today. Okay, that is not what I want. I want the shell script. My brain and my fingers are not connected. All right, if I forget to do the CD ... I think was the point I was trying to make, and leave this line in here. Forget to do the cd dot dot. Notice that this command isn't going to work because the directory that I've told it to delete is the directory that I'm currently in, which is not how this command works, right? I need to tell it to remove a directory, that is within the directory that I'm currently in. So if you run this exercise without paying proper attention to your position, you can see, right, remove directory, failed to remove test2, no such file or directory. Why did that happen? It happened because in the script, gosh, come on now. In the script, it CDs into this directory, but it never CDs back out. So when I try to run the remove directory command, it can't find the directory that I'm trying to delete. You have to pay attention to where you are at all times within your script in order to make sure the commands are going to work properly. All right. Let's talk about loops and if statements. That's our next task on the list. They are just as handy for us here as they are in other programming languages. So I'm going to start out actually, surprisingly, perhaps, with what I would consider to be the less often used loop type with scripting. I'm going to go back to my prior directory here too real quick. Give me just a second. All right. I'm going to start with the for loop, which I would say is probably the less often used of the two, but still there. There's my directive up at the top, shebang bin bash. We do use the word for. Here is my loop variable. I'm calling it counter in, and then these are our curly braces. Here's the fun part. Do. We can now have it do a print statement. I have the -n flag in my notes, although I'll be honest with you, I don't remember exactly what the -n flag is doing for me here. I'm going to look that up in just a second to remind myself. Done. Let's break this down. The for loop itself looks kind of Python-y in a way, right? A little bit, sort of. The syntax, though, is a lot gnarlier than Python. Again, you got to pay attention to the spacing, the number of dots, like legit matters. You stick a third one in there, the whole thing's going to come crashing down, I promise you. So you got to be careful about stuff like that. Notice that the curly braces are used to define the range, but in order to define the body of the loop, we've got do and done. These are the curly brace equivalent if you're talking about Java or something, right? This stands for the body of the loop. The indentation is not enforced, but still definitely very handy to do. Please keep your code clean. It'll make your life easier. It'll make my life easier when I'm looking at it, right? And then, so yeah, this should hopefully do what you would expect a for loop to do. Let's take it for a spin. Okay, yeah, there we go. I did not print it out on a new line. Is that what the -n flag is doing for me? Yeah, why do I have, I don't know why I have it then. I probably prefer not to, actually. But take it out and see what it does. Yeah, the -n is, okay, interesting. Oh, yeah. I think it looks better this way. I don't know why I have -n in my notes, but this way looks a little easier to understand to me. Did effectively the same thing. Let's talk about our good friend a for each loop, because these are also handy to do. Shebang, bin bash. For variable name in, and now if I give it a string, right? Do echo f, done. So it's going to split that string for me automatically. Excuse me. Well, did it though? Can I prove that? I'm not so sure that it actually did. Let me see. Do I need the dash? No. Let me try this a slightly different way. What if we capture a command here? What if I say for f in the output of ls? Think about what that would do. That would give us the, yeah. This was something I was talking about just earlier today, right? What if I wish to capture the output of a command and then run a loop that goes through that output one at a time? That's exactly what we've done here. Let me put the script back up so that you can see the code. My first example did not quite pan out the way that I hoped it would, but this one, I would argue, is far more useful. Capture the output of the ls command, that's a list of files, iterate through that list, and have f take on each file name one at a time. One at a time. This is handy. This is very, very handy. Let's talk about if statements. I'm going to do it twice, once with math and once with not math, because that's what Bash makes us do, unfortunately. It's a little inconvenient. We'll start with an arithmetic example. I'm going to have the user type in a number. I'll read it in as n, capital N, and then I wish to do a comparison. Oh, there's my good friend double parentheses again. We've seen double parentheses before, right? Again, the fact that there are two parentheses, while seemingly redundant, does matter. It tells us that we're about to do some arithmetic. So I'm going to say if n is less than 10. Here's something else that's fun. Yes, I put a semicolon there. Yes, that was on purpose. Yes, that is where it goes. Actually, if you want to know the reason why, I can tell you the reason why. The parentheses command, these double parentheses, that's actually a command. That's not just a way of grouping order of operations in bash scripts. That is actually a command that is being run on the command line. So the semicolon signifies the end of that comparison command that is taking place. It's very different to how a programming language like Java would look at an if statement and execute it. But that's how Bash does it. So don't forget that semicolon. And then we're going to stick the word then in there. That's our open curly brace, right? That's our open curly brace for our if statement. And I'll just say, you know, number less than 10. This part doesn't really matter, just showing you how the if statement works. And then if I want to chain more, so like an else if, we're going to smash those two words together, elif. And if I want to, I can put another comparison. Well, with an else if, you have to, right? That's not optional. I can say if it's equal to 10, then and then finally else must be greater. Oh wait, we're not done. Our closing curly brace is the word fee, if backwards. Indicates that our if statement is now finally finished. I feel like I may have forgotten a then in here, to be honest with you, but I'm going to try it this way and see if it complains or not. And if it does, we'll figure it out. Let's do 15. The number is greater than 10, that's correct. Okay, so 10 Number equals 10, that's correct. 5, number 11, okay, cool, yeah. I didn't forget it then. It worked. It worked. However, the fact that I even said such a thing, right, is sort of an indication of how finicky this language can be sometimes. Counting the number of thens. Notice that I put a then after the if and the else if, but not the else. That's a little not cool, in my opinion, but that's what it is. And then like we saw earlier, in order to do comparison, or in order to do arithmetic, it's different than if we're not doing arithmetic. And that actually applies to our if statements as well, unfortunately. So I'm going to make another script for, not math kinds of if statements, which I would argue are going to be more common. These are the kinds of if statements you're probably going to have to use on the homework assignment. So comparing strings, right? Being a primary example, we can do like, and then now I'm looking for a specific name. The way to do that is with double square brackets, not double parens, but double square brackets. And then you can do string comparisons, right? So here's what an if statement would look like to do string comparison. Of course, just to make things extra interesting, well, there isn't a semicolon here, although now I'm kind of curious if I forgot that semicolon there. I guess we'll find out sooner or later. It looks like I did, actually, comparing my notes, just like we saw before. Need a semicolon after that. These are the kinds of things that when people will ask me questions about these scripting assignments that are one of the first things I look for, especially that variable one, that's with the equal sign. That gets people all the time. It's a really fun one. All right, let's give this one a spin. If I type in my name, it should hopefully recognize me, but if I type in, my daughter's name, it doesn't know my daughter's. So you don't know me very well, but that's okay. String comparison, that was the goal of that one. If I was comparing numbers, I'd have to swap those out for double parens, but since I'm doing string comparison, we're going to do double brackets, double square brackets there, along with the other syntax stuff that Bash makes us do. I've got a few more scripts to show you, but we're going to do another exercise real quick first. So let me pull that up real quick. This will be exercise 2. Here we go. Write a script that asks the user to type in 10 numbers and then computes a sum that are greater than 5. So you need a loop and an if statement. Right? Hopefully this shouldn't be conceptually difficult. We've all taken 131. But it's getting Bash to do those things that's going to be the tricky part here. Remembering that you need double what? Double square brackets, parens. Depends on what you're doing. See what things Bash complains about. so yeah. Oop. Let me get one of these. Thought I had a solution. I have an error. It says plus command not found. Any ideas?
Oh, you should put it in
Good call. Yeah, whenever we're doing arithmetic, we have to surround it in double parens. And so if you see this error message, arithmetic symbol, command not found, that's an indication that you're trying to do math and you didn't put the double parens around it. Another good thing to know, I'm stuck in the middle. It's waiting for more numbers, and I know it's not going to work. I'd rather not sit here and do it. How do I get out? Control C. Control C boots me out of my current command. I don't want to go through with it. Let me go ahead and open this back up and see if wrapping parentheses around the arithmetic that I'm trying to do here will help out. So before I was trying to do it without. Okay, so it accepted it. Well, I never actually printed out the sum is the problem that I'm now realizing. So maybe I should do that at the end as well. So that I can actually check. I'm going to type in 10 a few times just to keep the math simple, and then I'll type in 5 the rest of the time. 30. Yeah, I typed in 10 3 times. Those are greater than 5, so I counted those, added those to my sum. All of the 5s that I typed in afterwards were not greater than 5, so those did not count. Let me show you the solution that I came up with, and if yours is different, that's totally okay. I imagine that you did get stuck. You probably got stuck on stuff. I put another dollar sign up here. That's a habit that I have a hard time getting away from, is knowing when to put that dollar sign. But I caught myself. Don't have to do it when I'm assigning a variable. Notice I didn't put dollar sign here either. So assigning a variable, no dollar sign. But over here on the other side of the equal sign, because I'm referencing that variable, I actually want the value of that variable. There's the dollar sign. So, okay. That's one of the things that I screw up a lot. The equal sign, I think I actually screwed that one up too, because my habit at all was to put the spaces in. I actually like it better to put the spaces in, so to not put the spaces in actually sometimes requires me to think about it. Remembering that there's 2 dots here and the curly braces. All little fun syntax stuff that can trip people up when doing this for the first time. But yeah, this is a functional solution. Excuse me. And with the 20 minutes that we've got left, I've got just a few more things to show you. Plus, as promised, I want to talk to you about the homework assignment that's going out today. So, question, yeah?
I think there's a bug in this code. So if you input like turns 0 or turns 1, they will output nothing because the initializing of sum didn't work. Because if you run the output is like 0.
You're saying that this doesn't work?
Yeah, because if you input like 10 zeros, it will output nothing instead of the 0.
10 zeros? It'll output nothing? Really? I believe you. I'm just trying to wrap my brain around it. No, I got a 0.
Oh, why is it not working on one page?
Yeah, I don't know. I can take a look after class, maybe. Yeah, if you have time. I'm not surprised though. Bash is finicky, very finicky, and I have years of experience, which is why I don't hate it as much as I used to. I definitely used to hate it a lot. Yeah, what's up? When you're assigning, so when I'm assigning to a variable, I don't need the dollar sign. It already exists. Well, even here, it doesn't exist before this statement, but even then, I'm just creating it for the first time. Don't need the dollar sign. Anytime the variable name's on the left side of the equal sign, that's variable assignment. Don't need the dollar sign. If it's on the right-hand side of an equal sign, or if it's just being used as part of a command, you probably need the dollar sign. It's tricky. It's confusing. I understand.
Oh, I find out I forgot to add a space between the equal sign.
Forgot to put a space, or you mean smush it together, right?
Yeah.
Yeah, that'll do it. That'll do it. One of the more annoying syntax things about Bash. All right, just a few more things that I'd like to show you before we do a quick tour through the next homework assignment. The next one has to do with arguments. So remember that arguments are additional pieces of information that I can supply to a command. But if I want to write a command that takes arguments, I need to be able to access those arguments. So if you type in the name of an argument after the command, I have to be able to access that from within the command somehow. And so we have a way of seeing how many arguments have been given. These are defined to us in, these are special, I guess you would call them system variables, right? The dollar sign hashtag, that is a special variable that says how many arguments were used with this command. That'll make a little bit more sense when I show you this in an example in just a moment. And then if I actually want to access the arguments themselves, so let's say that I type in a command that has 3 arguments, right? In order to access those arguments, there are special variables for that purpose as well. So the first one would be in a variable called $1. Second one would be in a variable called $2, up until however many arguments there have. In practice, if you have a command with more than 2 or 3 arguments, then you're probably trying to do too much. That's a lot. That's a lot. I certainly wouldn't ask you to use more than 1 or 2 for anything that we do in this class. But let me show you what this is actually doing, right? So if I type the name of the command, the arguments are now anything that I type right now. So the first thing that comes is the name of the command. Then I can type in the name of an argument, and based on the script, it's looking for like a name, right? So if I say a name, it'll say total arguments 1, that's my name. It says hello Doug, right? Contrast that with if I don't put anything, 0 arguments. Okay, 0 arguments, but then $1 is empty. There is no argument, it's just empty. So it says hello nobody, right? If I want to, I can include additional arguments. So I could, put more names over here, like names of my kids. But I only ever use $1 in the code. I never use $2 or $3. So those extra arguments are just being ignored, basically. It still tells me that there's 3 of them, but I only ever actually use 1, right? So it's up to me to make sure that I'm actually accessing all of the arguments and using that information if that's something that I need to do for my program, right? Because you can't stop what the person running the command is going to do. They can always include as many arguments as they want. It's up to you to choose what to do with them. Okay. Another thing that is extremely useful to do is to determine whether a directory or a file exists. So, in fact, this is something that I can guarantee you're going to need to do on the next homework assignment that I'm going to show you here in just a second. Existence. Is that how you spell that? I don't know. Spelling's not my strong suit. Doesn't matter. So I'm going to ask them to type in the name of, enter in a file name or directory name. and then I'll read that into a variable. Call it, I don't like that variable name. Name is a good variable name. So I'm now going to write an if statement with a special flag, the -d flag for directory is saying if the value in this variable is a directory, I will treat this as a true statement and do whatever is inside of this if statement. Okay, so in this case, I'm just going to say, I'm just going to print a message saying that we're here. The -f flag for file, means that if I look at the contents of this variable and it is a file that exists in the current directory, right? Not anywhere on the computer, but in the current directory where I am, then that statement will be true. Otherwise, it's neither of those things, so I'll just say that. Alrighty. So I'm asking them to type in the name of either a file or a directory. If they type in the name of a directory, then I would expect it to trip the first one. If they type in the name of a file, I would expect it to trip the second one. Otherwise, it'll tell me that it's neither. Let's give this a test. If I look here, right, I see that I've got some folders from before. And if you don't, you can make one to test it out if you need to. And I've got some files here, too. So this script is called existence. Whoops. I made an error in my code. Let me figure out what I did wrong. Oh, I see what I did wrong. Anybody else see what I did wrong? It's a mistake I've already talked about at least a couple times today. I don't need the $ here when the variable is created. Read is assigning a value to that variable. You do not need a $ when variables are being assigned to. Yep, that's the mistake I made. If you needed more help, it did tell you line 3, right? It did tell you line 3 was the problem. Although this is a little weird. That's not really what I was expecting to see. But let's try it again now and see. All right, cool. So if I type in test, test is a directory that I was playing around with earlier. I don't know if you have that directory called test. You'd have to run ls to see, right? You can make a directory if you want to. But if I type in the word test, it tells me, yes, that is a directory. If I run this again and I type in the name of a file, so a file is basically, any of these will work, right? The txt files or the script files. I'll type in exercise2.txt, that is the name of a file. And it tells me, this is a file. This is a file. And then if I type in the name of something that is neither of those things, like my own name, it'll say, this is not a file or a directory that exists here, right? However, if I were to do something like make directory Doug, and then run it again, and then type in the name Doug, it'll tell me this is a directory, right? That's what I would hope anyway. Very, 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 very useful. And I've got one more example before we take a look at the homework assignment about reading in data from a file. One final script, and this is a little shorty script too. It's not very long, believe it or not. We're going to use a while loop. I only showed you for loops earlier, but we got while loops as well, and actually I think while loops are great for this purpose. While, read, line. That semicolon is required. Do, that's our opening curly brace. All right. Read, we've we've seen before. So this is just going to read in something. We've been using it to read in keyboard input, right? Whatever they type in. I'm telling you we're about to use it for a file. It can be used for both. That's the nice thing about it. How do I get stuff from a file into a script or a command? Anybody remember? This would have been from last week. I think this is the day I was sick, actually. Does anybody remember? How do I get something from a file into a command? I'm sorry? Yes. It's a less than sign. That's correct. The angle bracket. I would call that a redirect. That's the official technical term for it. This is, again, what would have been covered a week ago, I believe, when I was sick. So make sure to go back and take a look at that video if you need to refresh your memory on those concepts, because they will be a necessary part of the upcoming assignment. But if I were to, let me just make a quick little test file here with some simple information in it. If I wish to run my file and feed in the contents of another file to it, the angle bracket pointing to the left, that's a redirect. That is saying, take the contents of this file and feed them into this command. So anywhere that the read command is used within this script, it is going to take one line out of this file. That's why I have a loop around it, a while loop around it. So every time it goes through that loop inside of this script, it's going to read a line out of this file. Okay? I can show you. There it goes, right? Now in this case, it's just printing them right back out to us. But imagine if those lines in that file represented directories that I needed to go into. I could then use those lines from the file in conjunction with the cd command, perhaps. And then do some other stuff inside those directories too, if I needed to. In fact, that's exactly what I'm going to be asking you to do on the next homework assignment. So with the 8 minutes that we've got left, let's have a little chat about this homework assignment. There's two parts. One part, I'm asking you to get some practice with Vim. I put a file in the 237 directory on the server called Vim exercises, and it's kind of like what we did in class last week. I fully realize that you could open this in VS Code and not use Vim at all, but I hope that you don't do that. I hope you use this as an opportunity to practice. It's also worth a very, very small part of this homework assignment. So, the big chunk of the homework assignment is not the Vim practice. The big chunk of this homework assignment is for you to write a script. And you're going to be writing a script to grade the last homework assignment. So, for the last homework assignment, remember, or for those of you, I think most people have done it, or at least looked at it, right? There's a big old blob of text online. And I made you go find your whistle key in there, right? And then put that into a file inside of a directory. So I'm going to give you the big old password file and a bunch of directories from students, and you have to check those directories to make sure that the contents are correct. So you're going to have to look at the file and make sure that they got the right stuff in their file that exists in the big old blob of password text, right? You're going to have to visit each student's code one at a time and check to make sure it's correct, and then give them a grade. These are fake students, of course. I've made a fake data set. Actually, my TAs made a fake data set a couple years ago. You'll recognize the names, I'm sure, of some of the people at least. But there's a data set here that you can use that has these fake assignments in it. So here are the students for the course. They're inside of directories, right? They're inside of directories. Here is the big text file with all the gibberish in it that has whistle keys buried in here, right? Where the whistle keys are also given to you in this fun little file here. Here's all the whistle keys. Here's all the whistle keys of the students in this fake course. So you are writing a script that is going to visit each one of these directories, examine the contents of that file, except not everybody did it properly. So some people are in the class and they made the directory, but they got the wrong stuff in the file. You're going to have to detect that and give them the proper grade. Some students didn't even make a directory. They didn't even get that far. So the instructions explain what grades you should spit out, right? Down here you can see grade of 0 means that they didn't even get the folder made. Grade of 1 means that the folder exists, but they don't have the file. Grade 2 means they have the file, but the contents are wrong. And a grade 3 means they got all of it, all the parts. One final thing that I want to say about this assignment, right? I know students, this is somewhat of a tall task that I'm asking you to do. However, I have shown you every single thing that you need to do this assignment in this class today. I'm going to make sure all of these, I'm pretty sure these scripts that I've written in class today are already on Canvas, but I'm going to go double check and make sure after class that all of these scripts are on Canvas. You literally could take the script examples from class today and just kind of rearrange the parts, right, to make the solution to this assignment. That is sort of the intent. That being said, I always get people who go way off in a different direction. There are other ways to do it, so if you find yourself in a Google rabbit hole, I'm not necessarily going to stop you. I do think you might be making it a little bit harder on yourself, because again, I have given you all the tools, all the building blocks that you need to do this assignment. You have them. They're in the examples that we did today. There is nothing that you need to complete this assignment that we did not talk about in this room today. So please keep that in mind. I guess some of the commands and stuff that we learned last week, you'll need those too, right? But as far as the scripting content goes, if you understand today's examples, then you have what you need. One final thing to point out as well. This is the exact command that I'm going to use to run your script. So I would highly, 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 highly encourage you to run it this way. And one other very important point I want to make. I've already seen some people, well, this should not be done on the server. So SSHing into shell.cec.wustel.edu, we will do that sometimes, yes. This should not be done on the server. Keep in mind that if you are in the 237 directory, right, everybody in the class can see that. So if you're working on your script in that directory, everybody in the class can see your script. I do not want that. I don't think you want that. You should be working on this on your computer. Do not use SSH when working on this. Just do it locally on your machine. Download the files onto your computer that I've linked you to and work on it on your computer, and then submit the script on Canvas once you are satisfied that you've got it working. Okay? Any questions right now? I've tried to make sure to cover the pain points that I know I've experienced in the past. Yes?
For submitting the script, it's just gonna be like a text box.
It's a file upload. File upload, yep, and I'll download all the files and run that exact command, yeah. And hopefully get the output. I actually sneak a few more students into the roster before I do it, just to do some extra checking, but yeah. Yes?
So like we can't just
You're given a file with Wusel keys in it. So if I want to add more students to the class, I just have to add more Wusel keys into that file, and your program should adapt accordingly. You should check and make sure those directories exist and that the contents are good. Yeah. In other words, I want to be able to run this script on any group of students that I've got. If I do this assignment again next semester, I want to be able to run this. I have the script, right? I literally use the script to grade your first homework assignment. It exists. I'm asking you to write it. That's quite literally what I'm asking you to do. I'm going to run this script that I have on your homework assignment tomorrow. That's my plan. And then I'm going to ask you to write it and send it to me next week. So that's the goal. Let me know if you have any questions. Let me know if you have any help. That's going to wrap it up for today, all right? I'll stick around for a few minutes if anybody needs help on the last homework assignment or needs anything at all. Yeah?
So I was looking at the exercise one.
Yes.
I was taking out the getting out of directory. So I should state this,
Well,
or should create a directory like I.
it's a little confusing, and I did see hand waving. Yeah, you know,
Yeah, it doesn't bring me
the script does. The script does. I promise you. 755 is a common one. That means you can do everything with the you did. And X. So 5 is read and X. I was not possible for a script. If it's something that is not a script for a program, it's just text. I'm not sure what the file is. Is that your directory on file? Well, then the directory. Okay, yeah. I mean, if it was a directory, then how to go through it? Well, let's talk about the
Like this class doesn't matter. I'm taking that class pass fail too.
Oh, I'm taking house fail.
Yeah. I said don't matter. Like,
Have you finished lab 1?
what? I won't push it off.
I'm sorry. I'm sorry.
I can help you.
Oh, really?
Yeah. Actually, maybe not. Maybe not this week. No, 15 months before.
Yeah.
It's like this week on
Crazy. Crazy.
I'm busy, bro.
Dude, I'm busy too. We're